combustion units, so a gas engine with an electrical power of 1.7 megawatts. And at the end, we produce around 12,000 cubic meters of liquid digestate and around 4,800 tons of compost, which are used as a biofertilizer for around 1,000 hectares of agricultural land around. And our ongoing developments, we develop major biogas plants with sugar industries in order to give value to the residues from the sugar industries. As you probably know, in France, we don't harvest sugar cane because the climate is not in favor of that, but we use sugar beet pulps. So sugar beets, sorry, to produce sugar, and then we digest sugar beet pulps in mixture with vinasses and sewage sludge, and this biogas is then purified and injected into the gas grid. And we purified it to biomethane, and here we have a partnership with Fischer, which is a German engineering company, and their offices are located in Göttingen. I will move to the next slide to show you, because in France we do not yet have built such a plant, but we are in project with several sugar companies in France. But this is to show you an example of a sugar biogas plant built by Fischer, our partner. It was built in 2001, and it processes as I said, sugar beet ends, sugar beet leaves, sugar beet pulps, and vegetable waste. You can see that's a huge amount of a large amount of tons, 114,000 tons per year. The digesters are quite big. 4 times more than 4,000 cubic meter, and they are in coated steel tank. This special steel avoids corrosion problems because, as you can probably know, the biogas is quite acid and contains some acid, and you have to protect the steel in order to avoid corrosion. And here in this site, plants. So here we digest dung, manure, culture residues, and energetic plants that is silage. And the biogas is used in CHP units or injected into the gas grid after purification into biomethane. And there we have a partnership with Valogreen, which builds turnkey farm biogas plants. I will show you the Valogreen farm biogas plants. In France, there are 35 existing farm biogas plants built by Valogreen. And Valogreen has a low-cost and efficient license process. Why low cost? Because the digester, as you can see on these pictures, are located into several silos that allows limited civil works. And as you know, that these silos are very current, and I know in Brazil you have plenty of this kind of silos, and they are specially designed with a liner inside the silo, including a gas holder. So that means that in the top parts of the silo here, you have a gas holder. There is no mixer inside the digester, so because we want to avoid a maintenance problem. And the mixing is performed through a shredding pump. You can see here the the shredding pump and the recirculation of the digestate. So we extract digestate from the digester, it's shredded and re-injected. And we take also the opportunity to inject a little bit of biogas. So that means it creates density differences into the digester, and this allows a better an improvement of the mixing. And also one benefit of shredding is that each time you recirculate, you decrease the size of the particles, and so the kinetic of, as you know, the kinetic of degradation is improved through this reduction of the size of the particles. So our experiences in Brazil, we participated in a low carbon business action in Brazil. I don't know if you know this program, it's called LCBA, and we were associated to 3 various projects. And I will try to shortly describe these 3 projects. We had a partnership with SGAM Energia for development of a farm biogas plant, and it was decided to create this farm biogas plant in a fazenda called Alvorada, located near Vilhena, so it's in Rondônia state. And we perform a technical and economical feasibility study for processing of 20,440 tons of cattle solid manure mixed with 500 cubic meter of cattle liquid manure. And we propose to add to this 2,400 tons of corn silage per year, because as you probably know, the manure are not so high in the potential biogas potential of manure is quite low. So if you want to improve the production, you usually add some energetic crops like a corn silage in order to have at the end a good production by cubic meter of digester. And this allows an annual production of 805,000 cubic meter of biomethane per year. And this project was, in fact, I would say not. We decided to forget this project because this was very far away. Rondônia state is very problematic on the logistical side. Then we had a partnership with the ACCS, it's an association of pig producer in Santa Catarina state, and this was we worked on development of a farm biogas plant in Fazenda Chesca, located near Salto Veloso, so in Santa Catarina state. And there was a technical and economical feasibility study for processing of quite a large amount of pig manure, because there are, as you know, many pigs in this area. 21,900 cubic meter of pig manure mixed with 1,460 cubic meter of cattle manure. And here again, we decided to add 3,500 tons of corn silage per year. This allowed an annual production of 518,000 cubic meter of biomethane. There are some projects going on in Santa Catarina, and we are still in contact with ACCS in order to promote our technologies. We had then a partnership with Biogas. I suppose that the people that knows the biogas in Brazil know this company, I would say this association, which is quite implied in biogas development, located in Iguaçu, in Foz do Iguaçu. And so for development of an industrial biogas plant in order to process organic residues coming from the sugarcane industry, located in Batatais in São Paulo state. And there we perform a technical and economical feasibility study for processing of 7,500 tons of bagasse, 16,000 tons of filter cake, and 80,000 cubic meter of vinasse, which allows an annual production of 2,600,000 cubic meter of biomethane. Our experiences in Brazil, our active participation in the LCBA program, allowed us to visit several biogas plants in Brazil, and so to have a good knowledge of the potential improvements in designing the future plants, especially, for instance, in Santa Catarina state, where, for instance, there were many lagoons, and we no mixing facility into the lagoons, covered lagoon, I mean, for digester, and there was no, for instance, processing, first processing of biogas. So it's very important, for instance, to remove H2S from the biogas in order to, I would say, to guarantee that the gas engine will not suffer from high corrosion inside. And so you will have very high cost maintenance costs. We also established many contacts with potential suppliers of various equipments, such as silos, covered lagoons, mixers, shredders, pumps, screw press separators, decanters, biogas engine, biogas upgrading systems, sensors, and process control. Our strengths, we have a strong expertise in construction and operation of biogas plants with different sizes, from large industrial plants to small farm plants. We participated in research program on co-digestion of various waste, so called the program called CODIMET, and the valorization of the digestate program called VALODIM. We are quite active participant in the biogas commission, so now it's more bioenergy within the industry and agro resource cluster in France. So for IAR, I was the president of the biogas commission for a few years, and I am an active member of IAR-do Brazil. So in conclusion, I would say as you know, the available biomass is huge in Brazil. So there is a very high biogas potential in your country. And Fertigaz is ready to provide its expertise in order to develop the biogas sector. And as I said, under optimal technical and economical conditions. We are looking for Brazilian partners in order to implement biogas plant in Brazil. And at the end, I thank you very much for your attention, and I am ready to answer your questions. And I'd like to end my presentation with these words coming from Antoine de Saint-Exupéry. We do not inherit the earth from our ancestors, we borrow it to our children. Okay, so thank you. And I will be happy to answer your question if you have some.
Thank you, Eric, for this presentation. It's a very good presentation, give an overview of the action of the Fertigaz in France and in Brazil. Do you have a question to Fertigaz, to Eric? Please, it's possible for you to ask different to ask it on this subject. Do you have a question? No?
Yes, I have one, if you allow.
Okay.
This is Andrea from Top Industry. We are a French company specialized on high temperature and pressures processes. Okay, we try to develop, for example, methanation processes for the production of methane starting from CO2. And I have a question, because in France there is a lot of interest rising up between the coupling of for the coupling of this process of methanation to the methanization process. How do you think about it, Eric?
Yes, you are right. It's a very good question. Yes, yes, this topic is still, as you can understand, is still under research in France. But it's very important because, but Mohamed could also answer, I think, to this question, because there are a lot of research done on this subject, because in France, the main gas distributor want to try to, I would say, to replace all the fossil gas with renewable gas, and there is an aim to reach this objective in 2050. So, in 30 years, France would be able to produce all its gas and will not import any more fossil gas. It's quite ambitious, but it comes from three main possibilities. First, biogas, yes, for approximately 1/3 of the biomethane, and then methanation, and this could contribute to also about 1/3 of the coming production, and also power to gas. I don't know if you know what is power to gas. You use the renewables to make water hydrolysis, and then also to recombine CO2 and H2 in order to produce syngas through methanation. Yes, and you know, sorry, there was 1/3 also coming from pyrogasification. I was wrong. 1/3 coming from biogas, 1/3 coming from pyrogasification, and 1/3 coming from methanation through power to gas. So there is a lot of research done in France on this subject, which could be methanation, also biological methanation, but it's still under research, as you can understand. But it's a very important topic for the companies which are distributing gas in France. Maybe Mohamed, you could add something. I don't know.
Yeah. Yes. I agree with Eric. Yes, now methanation is, I think, is a future solution in order to improve the productivity of the different production process of biomethane, because now we have several challenges. For example, to reach the different productivity explained or described in the law in France, in order to the biogas market grow to to become a new viable economic. And you have a different, it's possible to work on the different solution. Biomethanation is a new technology, I think is a university step. And I don't know, we have now the industrial production for biomethane with methanation processes.
Yes, so maybe I didn't explain well. Top industry provide methanation plants.
Yeah.
Catalytic methanation plant.
Yeah.
For example, if you know the Minerve project in Nantes, we built it, and we are trying to develop such plant at industrial scale, at least a pilot industrial scale.
Yeah.
We are trying now to couple this technology with exactly the methanization one. Okay. Yeah. And this is the aim of my question, because Eric already developed a lot of plants of methanization, for example. Yeah. And I would know just its feeling about it, because we are seeing a lot of interest. Okay, but there is still a lot of problem too. The cost.
What kind of methanation did you develop? It's a biological methanation, or
no, catalytic.
Catalytic, okay.
Yeah, catalytic methanation. It is most in the well, in United States, for example, there is already at industrial scale. So okay, it was just to have a feeling of a specialist as Eric in order to and the methanization plant development.
Yeah, but I have a question for your solution. We can combine your solution with agricultural methanization, or industrial.
we are trying to develop to make the scale up. Okay.
Yeah.
Starting from the lab, we made the first demonstrator in Nantes. Of course, it is just a proof of concept, one nanometer cube per hour. Okay. Now we are trying to develop the industrial scale plant. Okay. And we are trying to put in place projects with in order to couple the next demonstrator to methanization plant. Why? Because we are pretty sure that it would be maybe replace the upgrading process, because into the catalytic methanation you can inject the mixture of biogas outcoming from the methanization. Of course, purified from the sulfurs, but you can inject the mixture. So,
yes, because in that case, you will increase a lot the proportion of CH4
yes,
by methanation, obviously, and you remove a lot of CO2. So it means that you don't have to separate the remaining CO2 after this process, I guess.
Yes, yes. This is the reason. We reached yields of around 99% transformation. So
interesting.
Okay, it was just the question in order to have the mind of methanization developer about this question.
Mr. Michelatti, it's possible to discuss on these topics after the meeting?
Yeah, yes, if you want.
Okay. So, do you have another question? Anybody? No? Okay, thank you very much, Eric.
Okay, so good morning, everyone. So I'm Alexandros from Central Supelec, and I will present you a presentation on modeling and optimization of processes for the competitiveness of bioenergy sectors. So first, I will just present you quickly our laboratory. So we are a laboratory research from Central Supelec, so the share of biotechnology. And we are located in France, so in the Grand Est region, inside the industrial biorefinery, so the Pomacle-Bazancourt biorefinery. And we are part of the European Center of Biotechnology and Bioeconomy. So inside our laboratory, we have one aim. So our ambition is to develop a virtual and operational approach for the bioindustrial plants. So our idea is to come from some problems, so just from researchers' ideas or industrial issues, and developed both micro experimentation and modeling in order to create then simulation and go on validation directly on a pilot scale plant. And so this concept is named digital twin concept. And the aim of this concept is to observe at microscale, to measure also at microscale, to understand. And the understanding will help us to make modeling and then prediction to accelerate, in fact, the scale up of the processes. So in the laboratory, we have three main axes of research. So the first one is dedicated on lignocellulosic biomass, where we study different type of biomass conversion. So we first studied physico-mechanical characterization of the biomass. And then we studied two main ways of conversion of this biomass. So first, to go directly on bio-based materials, for instance, for building or transport markets. And we also studied the conversions by treatments of the biomass. So on different treatments processes like grinding, drying, torrefaction, acid cooking, or steam explosion. We have the second axis on biotransformation, where we study the biological conversion of biomass into compounds of interest. And our aim of this axis is to optimize the bioprocesses by studying the influence of the environment or to study the phenomena inside the process in order to better to have optimization on the energy, for instance, also on the design of bioreactors, etc. And the third one is the downstream process axis, where we study the extraction, the separation and purification of compounds of interest by different technologies. So we will see some examples after. And with these three main axes, we have a base frame on modeling and simulation, where we developed our own laboratory instrumented prototypes in order to have a lot of figures, etc., to go on phenomena modeling. And then with high performance computing, we can make some predictive simulation and numerical scale-ups. We have also 4 different platforms to support our research. So one platform is dedicated on pilot plants, so where we validate our simulations. We have also a platform on instrumentation, where we make some the conceptions, the design of experiments and sensors, for instance. We have a platform of imagery and a platform, chemical analytics platform. So now I will show you 3 different examples of research works carried on bioenergies. So one dedicated on the study of pretreatment process, one on the gas purification, and one on byproduct valorization. So the first example is the study of the steam explosion. So in the bioethanol production, we need to have some pretreatments on the lignocellulosic biomass to convert them in biofuels. So the pretreatments allow to make carbohydrates accessible for enzymatic hydrolysis. And then the enzymatic hydrolysis will liberate sugars that can go on fermentation. And inside the different pretreatments that already exist, one that could be interesting is the steam explosion. The interest of this pretreatment is that there is no additional solvent inside this process, contrary, for instance, to acid cooking. And the steam explosion process is a combination, in fact, of 2 different steps. So we have the first step on hydrothermal treatment plus sudden decompression. And we have already seen in the past that the biomass alteration during the step of hydrothermal treatments have really important impacts on the explosion step. And the modifications can be seen at different scales. So we developed a study on a multi-scale approach of the biomass, lignocellulosic biomass alteration during the steam explosion. So the aim of this study was to develop indicators of the treatment kinetics in order to predict the conversion of the biomass during the pretreatment, and according to the parameters. So for that, we develop two different scale of study. So a micro scale approach, notably by imagery. So for that, we combined the Raman confocal microscopy that allows us to have the topochemical alterations of the biomass, and the X-ray nanotomography, which is a 3-dimension imagery at micro scale of the biomass. And that allowed us to have the chemical and anatomical changes of the biomass during the pretreatment. So here we have, for instance, the native wood. So we made this study on poplar wood. And then we have the image of topochemical alterations after treatment, a pretreatment. So we can see here the changements of the chemicals inside the lignocellulosic biomass. And we also developed a macro scale approach. So for that, we wanted to follow the rheology of the biomass during the steam explosions. And we developed our in-house experiments to follow the rheology during the experiments. So we have a scheme here of the developed device. So I won't describe all in details, but I can send you if you want some publication on that. And all this study allowed us to develop modeling, in fact, to identify and to predict the changes of the biomass in terms of physical and chemical characteristics. And by the modeling, we saw that the stiffness and the relaxation, so that can be at macro scale, can really well represent the indicators of the chemical degradation of lignocellulosic biomass during the hydrothermal pretreatment. So this is really interesting to adapt the parameters and to develop optimize pretreatment processes by steam explosion. So I'll now go on the second examples on gas purification. So we first worked on biogas purification. So in France, we need to make purification of the biogas if we want to inject biomethane in the network of gas. But the purification processes already available are not are quite expensive, and notably for the little scale methanization. So the aim of this study was to develop a cheaper and more sustainable and compact purification process, notably adapted for small production units of biogas. So we worked on the intensification of the classical water scrubbing of the biogas. So by CO2 absorption inside the liquid. So in order to intensify the process, we use the gas liquid membrane contactors. So we can see here what is the membrane contactor. So there is in fact, there is a lot of little membrane where the liquid and the gas go at counter current. And it allows to develop the surface of the contact between the liquid and the gas, and so to intensify the transfers between the liquid and the gas. So by the use of this gas liquid membrane contactors, we developed a process to purify the biogas. So process compact, modular, robust, and easy to use. We estimated that the capex is quite low, And we estimated also not the OPEX, but the energy consumptions. That is also quite low in comparison between with the other purification process existing. And with the developed process, we had the results of 97.5 purity of biomethane. That is, according to the law in France, okay with the injection of the biomethane inside the network, and the yield of 98.5%. So this process was patented, and we are trying now to demonstrate it at a more important scale, and to valorize it with a company. And secondly, we wanted to adapt this process on syngas purification. So the syngas, the hydrogen, need better purity to be valorized. And our precedent process didn't allow us to have this higher purity. So we made modeling, in fact, to see. So here we have an example of modeling, and we have modeling the transfers inside the membrane contactors and the absorption equilibrium. And this modeling allows us to see the obstacle. So that was the residual CO2 was due to the pH variation inside the process. So with this, the help of the modeling, we developed an adaptation and regulation of the brine inside the process. And by numerical proof of concept, by predictive product simulation and the validation on at laboratory scale, we developed a new process adapted on syngas purification that is also patented. Now the last one, so I will go quickly. We wanted to work on the valorization of byproducts. So the aim was to develop the valorization of the hemicellulosic fraction from acid pretreatment inside the bioethanol production. So in order to valorize high-value molecules to improve the competitiveness of bioethanol production. So here we have the conventional process where we go on acid hydrolysis and then neutralization with a lot of base. And our development of process was to recycle the acid catalyst, in fact. And for that, we used the filtration, so ultra and nano filtration, and conventional electrodialysis. And this process allowed us to recycle the acid catalyst by 80%. So that is quite interesting. With that, we reduce a lot the chemicals needs because we don't use base, and we recycle acid catalyst. And we also reduce a lot the mineral wastewater of the process. We have also an easier demineralization step, and we have a quite good sugar recovery rate with this process. So this process can allow to valorize pentoses from acid hydrolysis biomass. So this process is patented also, and we have some extensions in Europe, US, and also Brazil. So we are now looking for some partners to help us to demonstrate at a bigger scale and to valorize this process. So here I showed you some different examples of work we do. And we have also other research ongoing, like on biological methanation. So we talked just before on methanation, and we also work on co-digestion of microalgae, for instance. and we are always open to new collaborations on new topics. So thank you for your attention.
Thank you, Alexandre, for this presentation. It's very interesting presentation on the different technology to produce the bioenergy.
So, SENA Institute for Biomass Innovation. As you can see in my presentation, this is our facilities in here. We are at the Três Lagoas city at Mato Grosso do Sul state here in Brazil. We have actually 59 employees. Our work field are energy and sustainability and biotechnology. And these photos are our equipments in here that I will explain after some minutes. Here we are able to perform biomass pretreatment and conversion. We are able to work with several biomass that are industrial waste. It can be industrial waste, agro waste, forest waste, urban waste, wood waste, sugarcane waste, and so on and so forth. Some pretreatments we are able to perform in here are chemical process that basically are hydrolysis, biochemical process that are enzymatic hydrolysis, mechanical process that basically are milling and classification of solid wastes from the biomasses we are working with, and physical process that are basically drying of the biomass, and steam explosion with our reactor we have in here. Some process we are able to work with are fermentation, biocatalysis. I'm sorry, I'll get the point in here. Fermentation, biocatalysis, fast pyrolysis, gasification, biotransformation, hydrogenation, biodigestion, transesterification, and esterification of oils and fats. So these are the process we are able to perform in here. And the products and uses we are targeted are energy, ethanol, bio-oil, briquette and pellet production, biochar production, synthesis of gas, methanol, biogas, biodiesel, and chemicals in general based on biomasses. Our biotechnology field here basically are doing process involving process downstream that are recuperation and purification of bioproducts, biocatalysis and fermentation, optimization of bioprocess, cultivation of microorganisms for producing enzymes of interest, biorefineries, and development of technologies for biofuels. For energy and sustainability, we are able to perform fast pyrolysis and gasification. We are able to develop biofuels like ethanol 2G, biokerosene, green diesel, biodiesel, HPO, HEFA, biochar, pellets, and briquettes production. We are able to perform catalytic process and scale up of biochemical process. Those photos are our equipment in here for fast pyrolysis and the steam explosion. This is a steam explosion reactor. Our customers and partners. We have some partners in this image, and as we can see, there are some partners that we have more than one projects with them. Like this one, we have 4 projects, two. This is to show that we are always getting some rebuying of our projects in here, and we are working with pulp and paper industries like Suzano, Eldorado, Brazil, and bioproducts in general, like Soleá, like Grambio, and so on and so forth. A case for you, a case for thermal conversion, we have performed here. Fast pyrolysis of biological sludge. This is the sludge. We had to perform the fast pyrolysis for thermal conversion and production of biochar. That's in this photo here. Bio oils. That's the light bio oil and the heavy bio oil, and the biogas that we are able to isolate to. Our infrastructure is divided basically in three fields. That's the thermal conversion of biomass and the bioprocess. And to support those two, there is an analytical methods, a field for analytical methods in here. The thermal conversion equipments that we have in here are pyrolysis in packed bed in a laboratory scale, pyrolysis in fluids bed in a pilot scale, gasification in packed bed in a laboratory scale, and gasification in fluids bed pilot scale. We also have milling and classification of biomass equipment and with equipments for pad production and briquette production. For bioprocess, we have some bioreactors varying from 0.5 liters to 100 liters. This is for scale up of bioproducts. The molecular biology equipments are equipment for PCR, that's polymerase chain reaction, and real-time polymerase chain reaction. We also have the equipments for electrophoresis and so on. The analytical methods we are able to perform here are the NIR, that's near infrared spectroscopy, the FTIR, that's the Fourier transformation infrared spectroscopy, the UPLC, that's the ultra pressure liquid chromatography, the FPLC, that's the fast protein liquid chromatography. We have equipment for analytical pyrolysis. We have GCMS, that is the gas chromatography with mass spectroscopy, but we also have the FID, that's the flame ionization detector, and TCD, that's the thermal conductivity detector. And also we have the STA, that's the simultaneous thermogravimetric analysis. That is to perform the TGA and DSC. TGA being thermogravimetric analysis and DSC being differential scanning calorimetry. This is my presentation for now. I hope you feel free to contact us to any question, any idea, any suggestion you have. Just to remember, we are the Senai Institute for Biomass Innovation. My name is Tiago. My email is tiago.almeida@ms.senai.br. And our phone number is the one I'm showing you here. And thank you for the organization. And if you have any question, I can try to answer, or you can email me, please, and I will send you the answer with my colleagues here, my co-workers that can help me to.
So, thank you for your invitation. Today, I'm going to present you what we are doing, BioEntech. So, optimization of energetical and environmental balance for biogas farm, industrial, and urban wastewater treatment plants. We are now, we have 7 years of experience. We improve energy and environmental performances. We did equip 40 treatment facilities. When I'm talking about treatment facilities, is biogas farm, what we call in France co-digestion. That means that you take all kind of waste to produce some biogas, and wastewater treatment plants. We have 3 range of products. It's a suite of software, the Memo, analytical tools, and those tools, that means software and analytical tools, have one aim, is really to control and to have a better performance on this kind of units. So the key points of our solution is what we can call the digitalization of bioprocesses, is Industry 4.0. We do that through modeling approach. The advantage of that, it's real-time control of bioprocesses, is the security of the biology, to increase the production and to reduce operating costs. We have 300 million tons of solid waste and 30 million cubic meter of water waste, which is really tremendous. And in this, you have only half of it that is really treated with a facility treatment like compost, wastewater treatment plants, or methanization units. And just imagine that if we could, just in Europe, and I imagine that Brazil can be as well very tremendous figures, if we could just treat 100% of it, it will save 5 billion euros per year, which is a burden for the communities, and creates 1,000 of jobs and reduce the green gas emissions. This is the big picture first, before entering to details. After, don't worry, I won't make again the presentation, but maybe just to put pictures on my saying that with the digester, we have one unit to identify the substrates, because now the waste need to be a resources. And if you want that the waste is a resources, we need to know what it is. The snack, it's the Minilab system, and the Memo, it's a software to take all of the information. With that, I think you understood that we make services with our system. Is SaaS mode. That means it's 24 hours a day for the Memo and the snack. You have here the benefits of the Memo. I explain you. I remember that. The key point is you optimize the treatments, thanks to real-time analysis. We are looking for the biological stability. We do that with a model. That means a digital twin of the installation. And the idea is really more than the idea. The goal is really to decrease the operating cost and to increase the biogas production. Some pictures for the snack with the hardware, the possibility to build it directly in Brazil, and that's we make the algorithm. But since we have an internet connection, we can do that all over the world. And the idea is to make tailor-made services for different units. That means biogas plants will have a different issue in Brazil than in France or elsewhere. The IAR scan, I think I was there, is just to give you an idea of what is your substrates with the sugar, proteins, and lipids, the kinetic, and all of this information allow you to really better know your feeding soup, because it's a key parameter for a biogas plant. And once you know that, you can really set up and generate feeding suggestion of the digester to stabilize the production of biogas and to increase the production of biogas. So the case studies, and again, thank you for the people who tell me that I was not sharing the screen. The case studies, I did 3 of it. The first one, it's in agricultural biogas plants. Well, it's in France, the energy production, it's 800 kilowatts, a little bit more even. You can see that here, it's quite simple to understand. Before crash, everything was okay. They had in the feeding one substrate that was not good for the biomass, and that makes big disturbances. And the disturbances you can see here with the electrical power and with the VFA. So you can see that the VFA, the volatile fatty acid, it's one of the main inhibitors. And what is good to show is that if you have an increasing of the VFA, it goes to the disturbances. That means it's not linear. I mean by that you can have a bigger peak of VFA and without having any trouble of your production. But here, at least, it's quite clear. So to come back on the feeding, to just say we stop this kind of waste and now we go to another feeding, and you follow the suggestion generated by Memo, so you can see that we have a faster recovery, and we have the biomethane production, which is more linear. And from the disturbance phase to the follow-up suggestion, it is earning of 22,000 euros per month for this kind of unit, with the green French tariff, of course, as you can see in kilowatts. Second one, it's on the brewery. We're working. I don't know if you for sure you did not see my screen at the first. But we're working with big companies like Carlsberg, Heineken, Tessa, for the people who knows. They're making syrup, Veolia, Suez, Engie. So we have a good portfolio for agro-industrial as well, for rockets, if you know all the stuff. So this case study giving you for a brewery the idea of what can do this kind of system by taking in account the entire wastewater treatment plant with a digital twin. The question for them was not to produce more biogas, because the biogas, they burn it in a boiler. So for them, they have no green tariff. But what was very important for us is really to make saving on the steam. And just we had the command of the steam directly connected to the biological state of the process. That means that for this loop, we just decrease the temperature of the AD reactor. It's for effluent, so it's very, very fast. It's like 8 to 12 hours residence time. We just decrease the temperature from 38 degrees to 28 degrees without damaging, without stopping the biomass activity. And we make 80,000 euro saving over 12 months on this single loop. Last case study, it's on agro-industrial for wastewater treatment plant. Again, more in the long-term strategy is really the first unit. It's where we make a scale-up of it, industrial scale-up. And you can see that 2012, 2013, they were with 2 main stops. I think the graph is very easy to understand in the kilogram COD per day. And of course, if you drop down, that means that you process less COD, and that is, it's more costly, and your reject to the river are, of course, polluted. And in France or in Europe, you can have really heavy taxes on it. So the idea is stabilization of the units, improve the COD allowance, reduction of sludge production, and reduction of caustic soda. And since we started, it's an estimated saving of 80,000 euro per year for that. Again, in the same cases, as a long term, you can see that in orange salmon color, that the organic load corresponding to risk of acidosis before the installation of MEMO with 2 production shutdown I told you about. So that means that now, by more controlling the effluent, they can pass bigger amount of effluent. And after 6 years on site, MEMO continue to guarantee the performance and safety of the plant. Thank you for your attention. What does that mean? That means I think that I've been, I think it was in the key enabled technology 2018 in Brazil. I met very good companies, very specialized for agro-industry, as well for the biogas. You have many things to do. I think your country is very, very big. It's like a continent. And for that, to have this kind of tool, digital tools, to be able to give the know-how to operator for a simple farmer or on agro-industry business, well, I think that this can be a must-have to better perform your units and to preserve your beautiful countries. That's it. Thank you for your attention. And again, very sorry that you did not see my screen.
Thank you very much, Jeremy, for this good presentation, to have an overview on Bioenergy activity.
Let's start. Thank you very much. Thank you, the IAR in Brazil, in Portuguese, for the opportunity, and thank you all for being here. Well, I'm Maria Rolling. I'm the energy lawyer partner for the Rolim Viotti Leite Campos Advogados in Brazil. And today I would like to use my time, just 15 minutes, no more than that, to give you an overlook of the biogas legal framework in Brazil and challenges and opportunities for the future. See, just a quick presentation of our office. See, we are in market since 1993. We have 4 offices in Brazil, 2 in Europe, in Lisbon and in Germany, and around 120 professionals. We do all the areas in general, business areas in general, corporate law, and so on. But my focus in the law firm is the energy market, and I've been working with the power sector and the energy in general, power sector in particular, and renewables in Brazil for a long time. Well, and if you can go to our website to see more information if you need to. Well, let's see. My idea today is here to use my time, as I said, to give you an overlook how things work in Brazil in terms of opportunities for the biogas in particular, but it works for other sources of renewables as well. I'll follow more or less this idea of giving you an overview of the power generation. Let me see if I can see this. Okay. The power generation from the biogas, and then I'll show you the changes in the legal and the regulatory framework that are ongoing, and a little bit of the impact of the COVID that we had, not that much, we are recovering already, and some challenges for the expansion of the biogas in Brazil. Well, one first thing that I think it's very, very interesting to bring to your attention is the idea that the biogas is a source that is not well developed yet in Brazil, so it represents a great opportunity for investing, and it is a kind of a source that is inside the idea of the circular economy in a way that it follows the principles, which are to design out waste and pollution and keep products and materials in use, so it is recycling, and regenerated natural systems. And it is very important for Brazil because although we have other renewables in place, we need to advance the biogas agenda, because we need to use it to the impact of the biogas in the other sectors like the water, and the waste, and so on. The great thing in the biogas is because it protects the environment, but more than that, it gets a low value material, which is waste basically, to a higher value material, which is the production of electricity, heat, and the biofuel, bioenergy. To give you an idea of our mix of electricity mix in Brazil, which is already very, very clean. I think it's 2019, yeah, that's the data from 2019. Our mix of the electricity is based on water, hydro, basically 65%, and then we have natural gas, nuclear a little bit, just a small portion, eolica, wind is very, very developed in Brazil, well developed in Brazil. All our wind is onshore. We are now investing also in wind offshore, starting an industry in the wind offshore. And then we have part of it to the biomass, which comes 90% of our mix comes from the biomass. And from this 9%, we have 3% of the biogas. The others, the main source is the cane, sugar cane, but we are really focused today on the biogas, and we think that is the one that will grow faster than the other source in this particular thing. As you can see, from 2015 and 2018, the biogas power plants in Brazil went up for 119%, which is a huge increase. Most of them are located in southeast and south of Brazil. but there are potential in the other regions as well. And it is also, let me see here, I can't see. The biogas production is also increasing in the last few years. It started quite recently, because only in 2015 the planning started to look at it as a source to invest, and it appeared in our annual plan for energy. So now we think it will be evolving quickly, quite quickly. The potential that you are talking about, as you can see, sugarcane has been the domain, and then we have the source for the livestock and agriculture. Waste is something that is starting as well, and we have a new law in place that will develop the waste as well. And we believe that the biogas will be able to provide up to 36% of the Brazilian national demand for electric power, for the power sector, which is a huge expectation for the biogas, and it is just starting. Sorry, it's just even. Oh. Well, I'll show you a little bit of the framework that we have in place and the change that we are facing now. The institutional model in Brazil, in the energy area, is quite complex, but it's well defined, and we have a regulator, which is the regulator for the electricity market, transmission operated system, and a chamber for the commercialization. Basically, the authorities, the federal authorities, make the plan and the policy, which is a federal policy, and then we have the regulator to put in place the planning. And also, for the biogas, it's very important the energy, the planning that comes from the EPE, which is our energy enterprise research, that defines and plans all the energy investment in Brazil for the next 10 years, let's say. It is a kind of a sign for the investors, what they put in plan, and they are, since 2015, looking at the biogas market closely. We have a centralized grid structures, the transmission line, generation, and so on. And power sources are connected to transmission grid from the whole Brazil. Brazil has a very, very well-established grid, but I would say that the vocation for the biogas is much more in the distributed energy system here, because it is a kind of a source that depends on the regions, and it will develop more linked to the distributed energy resource, which is also, let's say, a tendency, a trend in the Brazilian market to become more decentralized with the time, similar with, let's say, in California and the other countries that went to a more decentralized system. I think it's a tendency in Brazil, a trend. Today we have in place a resolution from the regulator, which is the 482. It is under revision now, and it is based on a compensation system. The distributed generation in Brazil is based in a system when you use whatever you need for yourself, and then you put the rest of it in the grid, and the grid uses it when you don't need it. And you have the kind of a credit, the energy that you produce it, but you don't use it, and then you have 60 months to use it for yourself, let's say. Today we have a kind of an incentive, a subsidy, because the 1 unit of energy, 1 kilowatt hour that you produce, it is based on 1 for consumer. It means that you don't pay for the use of the transportation. That is something that is under review today, but all the plants that are already in place, they will keep this subsidy, let's say. The regulation, as I said, is under revision today, and the thing is to change the subject. These issues that are under revision are the change in the power compensation system. The idea is reducing subsidies over the time, and to introduce a kind of payment for the transportation. It seems a negative change, but I would say that it's a positive in a way, because we need to give time, to allow time for the distribution system to adapt to this centralized system. And on the other hand, we will preserve the contracts and the projects already in place, because they have a time for the payoff. We work together with the Biogas, which is an association for the biogas in Brazil, and we are in a work group trying to work with this change in the regulation. In the political arena, you are trying to highlight the benefits of the biogas, because it might be priced in the future, and in the distribution, together with the distribution agents, you are trying to come up to reach a common ground on about the timing to change the subsidies. But there is always this concern and this looking at the certainty, and to ensure that the contracts in place will be respected, and will be the projects in place will have time to pay off, and will keep the legislation that is on site today. Another news in the legal and regulatory framework that also impact the biogas, I would say that we have a new gas market in Brazil. The idea was to reduce the power of the Petrobras and to introduce more competition and the harmonization of the federal and state rules. So I think we have a much more business friendly environment in Brazil now for the gas market. And it has a positive impact for biogas, because the biogas can access the pipelines in the new market. So it's something that is not yet wrapping at full, but it might be the tendency in the future. So it's a positive aspect of it. In parallel, we are discussing the modernization of the electricity sector. The main driver is to open the market gradually, which can be also a positive impact for the biogas market, because the biogas has this trend, this vocation to be a decentralized source. And also because Brazil has a very, very clean mix in the energy sector, in the electricity in particular, but we have a lot of sun, photovoltaic and wind, which are not, let's say, which are intermittent source, so the biogas can compete and can complete this source very well, because it's thermal, so it will give us the stability that the system needs nowadays, because the other sources are water, photovoltaic, eolic, so we need kind of the stability in the grid, which will come either from the biomass in general, and biogas mostly, I think, and from the gas market itself. And we also have here one decree that is to provide financing for the projects, which is the priority investment projects since 2020. And the idea is to allow plants of biogas to have access to the green debentures, which are incentivized by the government to invest in in projects. Until 2020, the green debentures were only for big projects like infrastructure projects, but now they are extended to plants, small plants like the biogas. Well, the impacts of the COVID were really in the whole world, I would say. A lot of projects have been postponed, and the electricity sector, we could see a reduction of consumption, but it is already in recovery, I would say, because we know that Brazil needs to invest more in energy in the near future. So I think that it's not a permanent reduction in consumption. And we also have some postponement of power generation and transmission auctions in Brazil, but they might be back next year. And the long-term impacts, of course, there is a tendency to have an increase in the distribution tariff, which can favor the distributed generation, which is good for the biogas again. So we can see that we see a very good opportunity to a green recovery and to invest in technology for the biogas in Brazil at this moment, especially because it is a source that favors the stability of the system, the grid, and the projects are not so expensive as the gas projects and so on. Well, what are the challenges and the opportunities as we talk about? Well, in one of the challenges and also an opportunity to increase the biogas participation in the electricity mix. And it is something that you are already working with the authorities. Well, to raising awareness in Brazil also for the stakeholders about the potential for the biogas, and to increase the visibility of the benefits to Brazilian economy, environment, and especially for the sanitary issues. That is a big problem in Brazil, and the biogas plant can help with that. Financing to the bioenergy and biogas sector. As I mentioned, we have the green bonds in place, but we still need to have access to more investment, in particular from the international fundings. And also to promote regulatory stability. As I mentioned already, we are under revision of our regulations, so there is this concern of keeping and ensure regulatory stability for new projects. And to promote energy recovery, especially from agriculture, livestock, and waste sectors, we think that because we have a very strong economy based in these sectors, to allow this source to come together and to grow together. One specific program in place in Brazil, which has been a success is a kind of a small carbon market, I would say, a sector carbon market, which is the RenovaBio. Is a market-oriented mechanism based on 3 pillars. It is, you have, I think this one is better to show. We have the buyers, it is for the fossil fuels. The buyers have targets, annual targets and national targets and individual targets to comply with. They have to buy from green source. And on the other hand, we have a certification process for the new plants in place, which is a certification process based in the life cycle of the production. And then you have this market of CBIOs, as we call it. It has been a very, very successful program because all the stakeholders participate in the legislation, and we think that we will expand to other sectors in future. Well, basically it was what I had to present to you, an overview, a general overview of the market in Brazil for the biogas. I don't want to take much of your time, but I'm available to answer any questions or doubts that you might have.
Okay, thank you very much, Maria. there are the final presentation by Natalia Cerqueira from Ryzen Company.
Hello, everyone. Good morning, good afternoon. First of all, it's a pleasure to be here and have the opportunity to share a little bit more about Ryzen and what we have been doing. Let me just share my screen with you. Okay. So first of all, let me introduce myself. My name is Natalia. I work with the new business development team. I'm currently responsible for the ethanol, cellulosic ethanol deployment. We currently have, Ryzen is the only company in the world with an industrial scale for our cellulosic ethanol. I'm going to talk a little bit more about that initiative. But first, I think I'm not sure if everyone knows about Ryzen, and I'm glad to share a little bit of our history and some of our numbers before I get focused on what the renewable area is essentially. So Ryzen is an integrated energy company that was launched in 2011 and is a joint venture between Shell and Cosan. Royal Dutch Shell and Cosan, it's a big conglomerate that we have group here in Brazil that works with mainly energy as well and transportation, logistics, natural gas, and so on. And Ryzen was created and with a single purpose that was to fulfill the whole value chain of since the sugarcane cultivation in order to produce ethanol, sugar, and bioenergy, but also to distribute, to act on the logistics and distribution, the share retail, the proximity and convenience, as you have the convenience stores, the trading desk, that is an important asset that we have worldwide, and of course, the renewable energy. We are presented in all over the world, basically with administrative office, corporate offices for trading in Switzerland, Philippines, Singapore, and Houston. And we do have our mills production units in Sao Paulo and Argentina. And Argentina also will have a refinery there. And all over the country with our retailers, distribution terminals, airport bases, and so on. Talking a little bit about numbers, well, Ryzen has over 29,000 employees, 70 fuel distribution terminals and airport bases, almost 1 million acres of cultivated agricultural land, half of it as own area and the other half from third parties. 26 sugar mills, 1 E2G ethanol plant, 1 refinery, and it's missing here, but we also have 1 photovoltaic plant and 1 pellets plant. That is, this pellets plant is producing pellets from the sugarcane that I'm going to talk a little bit more. And over 1,000 Shell Select stores and 7,300 gas stations here in Brazil and Argentina. And then the results of all this infrastructure is that we are now the 4th largest company here in Brazil with investment grade by Fitch and Standard & Poor's. We do have a preoccupation in to have a massive reinvestment yearly in our operations to guarantee that we keep innovating and keep our system with the right level of security and performance. And we are the 2nd largest fuel distribution company here in Brazil. So talking about a little bit of about the renewable energy, it's important to say that we just created this vice presidency. It was created in almost 2 years ago, and we are divided mainly into power and renewables initiatives, not necessarily power in the latter sense way, but with renewables in renewables perspective. And our goal is definitely to lead the energy transition pathway, passing from a fossil-based economy to a renewable-based economy, and talking not only about ourselves, but also impacting clients, suppliers, and the massive stakeholders that we have. And we have this belief that is that biomass can definitely address and deliver all the sub-products that a oil barrel not currently do. So we believe that with the biomass, we can deliver not only energy, but also fuels, and biochemicals and plastics, bioplastics, and even asphalt. We can do it from the biomass. And this is mainly using our technology for the second generation ethanol. And putting here in, if I could divide our approach in that vice presidency, I would say that we have 4 main pillars, 4 main initiatives that are the strongest one that we are seeking and believing at this point. The first one is the second generation that I was talking about, and the one project that I'm responsible for its deployment. As I said, Raízen is the biggest company in the world with that facility that is located in the countryside of São Paulo, in a city called Piracicaba. Its capacity, it's up to 42 million liters per year, and we have produced and exported over 75 million liters at this point. And the thing that makes, I think, this project unique, one of the things, of course, is one is the land use, because we believe that and it's possible to produce up to 50% more ethanol from using the same land that you already have. So in countries that we don't have a broad agricultural area as Brazil, for instance, Europe, Asia, the second generation is important and can address that performance. Also, we can produce fuel and energy without taking care, without compromising the sugar production, for example. That is the lowest, the cheapest carbon energy source for the population, meaning we are not going to stop producing food in order to produce fuel, but we can do it both ways. We can keep producing your sugar, and also with the second generation ethanol, it's also possible to produce from the sugarcane bagasse, straw and bagasse, of course. Second of all, we have the pellets business that I mentioned. We just acquired that plant from our shareholder Cosan last year, and we have the capacity of producing up to 100 tons yearly of bagasse pellets. And we have exported over 50 tons up to now. So we have acquired last year, and we are producing massively. And we believe that pellets works as a battery in the end, because we're going just to compress the bagasse in terms of an energy format that it can be exported two regions, as mainly Europe, you have big generators, power generators, that we can displace the coal to using that pellet. Currently, we have a lot of some great companies that produce wood pellets, mainly in US and Canada, but we believe that the sugarcane one will have a lot of upsides, mainly because of due to the emissions. Sugarcane is a 1-year cycle. So in the year that you produce the cane, you produce the pellets and you burn it, you can put back together all the CO2 that you have put on the atmosphere. So this is a great upside for our product. The third one is our energy cogeneration. We have 13 cogens at this point in our facility from the 26 mills, meaning half of them are able to cogen. And we have, last year, we earned an auction for building the 14th facility. So currently we have 1 gigawatt capacity, and we are going to increase that number a little bit more. And if we put all the power generation that we have yearly, it would be possible to address or to comply, to meet the demands that a city as big as Rio de Janeiro has in terms of consumption. So it's a big amount of energy produced. And the third one is our biogas project. It was also an auction that we have won some years ago. This plant is located in a city called Guariba, next to our plant, our Bonfim plant, in a partnership with Bioenergy and Sebigas. This technology is unique because you produce energy from, you produce power from filter cake and the vinasse that comes from the ethanol production, sugar and ethanol production. And this is our first step of what we believe we are going to have as a biorefinery project. Because when you put all these projects in contact all together, we promote the circular economy. And one thing that is important to say here, that vinasse is always a problem for everyone that produces energy or produces ethanol and sugar. Everybody knows that, because in the end, for every liter of ethanol that you produce, it comes with more from 10 to 12 liters of vinasse. So in the end, we are actually vinasse producers more than we are ethanol producers. And we do produce almost 2.3 billion liters of ethanol yearly. So that project comes to address something that is really important to us, that is the vinasse itself, the circular economy, and a dispensable source of power, as Maria just mentioned in her previous presentation. And what I would like to reinforce here, that is E2G pellets and biogas are proprietary technologies from Raízen. So I think it's important, and we are really proud of that, because, well, we definitely believe, as I told you before, in biomass and, of course, in sugarcane. And this was, of course, just talking about the renewable energy, but we are divided, as I mentioned, into power as well. So the power division is divided into great groups. That is energy solutions, that we believe that we have this big road ahead of us to treat and to address customers' different profiles and needs. It is possible to help our customers to see how they can take more advantage of a greater performance and productivity when it comes to energy. And it's going to address mainly our objective in the first place is to attend our B2B clients and our retailers. And along with that, the energy solutions, as we call, we have the distributed generations. We just built a plant last year, also in Piracicaba, of 1 megawatt of installed capacity, just a pilot plant, and it is this plant allocated for our clients, retailers clients, and we have almost 20 clients there. And for this year and the coming years, we have the intention and the projects that are already in course to have more than 40 megawatts of distributed generation all over Brazil to attend our retailers mainly. And not forgetting, for us, it is Raízen really believes in a more sustainable world. So we are really not enthusiastic about all the renewable and the energy transition, but we have the concern of doing everything that we do in a high standard to meet not only our clients' desire, but because we do believe that we have to have the best performance, we have to have the best certifications, and we do believe that we have to do it in a sustainable and in a long view. So we are really worried about having the best certifications and to be able to put our products in everywhere it's possible to have it with specific, no matter what kind of clients, but to have to pass the tranquility of to them that we are selling something that is renewable, that has high standards, and it is environmental. It is environmental taking care. So, well, this is a little bit of what I brought here today in that presentation. We have a lot of things going on right now, but that are the main avenues and the main projects that we have been working on so far.
Thank you, Natalia, for this presentation. Very good, very interesting presentation. Do you have a question on this presentation, please?
Yes, I have one question. It's Jeremy from Bioenergy.
Yes.
So thank you, then, Natalia. It's a very impressive company, Raízen. You have really, let's say, a lot of facilities, a lot of plants. So my question is about the environment. You know that the sugar cane with the vinasse can be a big problem of pollution, for instance, or for bioethanol. In your presentation, you said that you were developing one big unit for biogas. So my question are as follows. First, what is Raízen's strategy regarding the environment? That means the sustainability. Secondly, just about this biogas cases, can you tell us more, just to know if it is working properly or not? Because I heard that it is a new, let's say, a new system. Thank you very much.
Well, thank you, Jeremy, for your question. I appreciate it. Well, first of all, talking about the vinasse, it is indeed a really big concern that we have. Here in Brazil, we are allowed to treat the vinasse and then put it back to the field as fertilizer. But of course, since we have a large production, we have to have another option to deliver that vinasse a more sustainable way, as you just mentioned. So this biogas plant comes also to address that issue. This plant has a 21 megawatt capacity. It's a large plant. It is already the fourth biggest plant in the world for biogas, and it's going to be launched officially this Friday. So we have been doing the commissioning. You were commissioning until this point. So our official launch will be happening now on Friday. As far as we could see, the performance of the plant is going well, really well. But yeah, we have to take a little bit more time and see how it's going to operate in a more sustainable and in a larger period. But nevertheless, I think it's important, and I would like to share here that we have bold plans for the biogas plant, because I think, and we do believe that it's possible to put much more facilities across our mills. Yeah, and have that huge potential for 26 mills. So we just put in the first one. We just see how it goes. If it goes as expected, let's hope for the best. We are going to build much more plants around that.
Good luck for that.
Thank you. Not sure if I left anything, any open point, remark for your question? Or?
No, I think you answered to this question.
Okay, thank you.
You have another question, please?
Yes, Eric Delacour speaking from Fertigaz. Yes, I have one question. You say that, yes, you are processing for biogas a mixture of filter cake and vinasses. I was wondering, did you think about also processing a part of your biogases in such a biogas plant? Because especially if you think about injecting biomethane into the gas grid, I do think that the biogas would have a better, you would have a better energetical efficiency through biogas than through cogeneration. So did you think about that or not at all?
Well, we do. Well, first of all, thank you, Eric, for your question. First of all, we do believe that it would be possible to have the bagasse itself, but we also have optionality for that use. So meaning, currently we use our bagasse for power generation in a cogen facility. We have the E2G, the second cellulosic ethanol production that also has the bagasse as a feedstock, and our pellets business also has the bagasse as a feedstock. So when we put all these options together to generate more power, we believe that we are betting more on the vinasse and filter cake rather than the bagasse, because we do have other destinations for that feedstock. And talking about the biomethane, I totally agree with you. This is something that we are looking at, and we have the desire to produce not only power, but also biomethane and replace our diesel fleet to biomethane.
Okay, thank you. Thank you very much.
Thank you, Natalia. Another question, please. No, it's okay. Thank you very much, Natalia, for your presentation.
Appreciate it.
Thank you. It's very interesting, right? And I think you have a very interest to build the synergy of the different energy and to valorize the different byproducts for ethanol production. And your presentation give a very good overview of your field. application field on the production of the several types of energy. Thank you very much.
It was a pleasure to be here and share a little bit more of what I've been doing. Well, I can share my contacts with you guys, and feel free to send me some notes if you have it, and if you want to share or have a deeper conversation in regards to any of these initiatives that you have been working on, please let me know.
Thank you for that.
Thank you very much.
Thank you, Natalia.
Pleasure.
I think it was the last presentation of this session. Sorry, Mohamed, to interrupt a little bit. Thank you everyone for having participating to this session. We propose everyone to join the process and technology session. Actually, very easy to do it. You just let's say if you have the last version of Zoom, you can go directly to the session yourself. If you cannot do it by yourself, you just leave this room to the main room, and we will forward you to the process and technology session. They are on the last presentation actually, and we would like to end up over there all together. For those who are present, who are registered, let's say on the B2B, don't forget, it's still possible to make an appointment, to request the people on meeting, and don't forget to have a look. Perhaps you have a pending meeting and you need to reply to it. Thank you, Mohamed, for the moderation of this session. Thank you all for your participation, and I see you all hopefully in the process and technology room. Thank you very much. See you there. Bye bye.
Thank you.